Alright, hello guys. So I'm gonna go ahead and do every problem from your review guide. Let's go ahead and start with number one. Again, you can kind of rewind, stop. You guys know the deal. But make sure if you're struggling with some of these topics, especially topics that you've really kind of don't know what you're doing, please do watch this video. It'll help out hopefully. On the first one, there is a bit of a typo. It should be y minus 2 instead of just being negative 2. Because this is an equation. So again, if I want to put this in vertex form, I do have to add by 2, so this should be y, and then plus 2 here. This is in vertex form now, right? This being your A part of your vertex, your H part of your vertex, and this is your K part of your vertex, okay? Now, if I'm trying to figure out vertex, again, set this equal to 0. I should get a positive 3. It is what it is, so this is just 2. So 3, 2 should be vertex. Now, you can find two other things based upon your vertex. You could figure out your axis of symmetry, which is sitting right here, and you can figure out your max or min, which is sitting right here. So, but we have to decide whether this is a max or a min, right? Again, this is a positive A, so this is a happy face, right? Which means it has a minimum. So this is definitely gonna be minimum. What is the minimum though, right? Again, minimum is sitting right here. So this is, again, the lowest point of this parabola is y is equal to 2. What is the axis of symmetry? Again, axis of symmetry is sitting right here. That would be x is equal to 3, okay? That's where, that's basically the equation that would split up this parabola into 2 equal parts. How many roots? Well, if I say how many roots, b squared minus 4ac should pop in your head, because this tells you how many roots. This has one job. So I need to figure out what a, what b, and what c is first, right? I can't really figure that out yet because it's not in standard form. So go ahead and put this in standard form first, and then you can figure out what these values actually are, okay? So let me go ahead and do that right off to the side. Alright, so I do figure out my equation, which is, again, this is in standard form, this is in vertex form. I do figure out that it is y is equal to 2x squared minus 12x plus 20. Again, I just simplified. That means a is 2, b is negative 12, and c is 20, okay? I need to go ahead and put this in b squared minus 4ac, and I do end up getting negative 16. Well, negative 16, that means this has no solutions, okay? If it's greater than 0, 2 solutions. If it's equal to 0, 1 solution. But if it's a negative number, like this, then you have 0 solutions. All right, let's do E, F, and G, right? So we figured out, well, this equation, okay, whether it's in vertex form or standard form, has 0 solutions. Well, if it's asking what are the roots, well, that would just be none, right? This has no roots. It crosses nowhere on the x-axis, right? And I'll kind of show you when I sketch here. Y-intercept, right? To find y, we make x 0. So let's go ahead and write this down real quick. And let's make x 0, right? 0 minus 3 is negative 3. Negative 3 squared is 9. Okay, 2 times 9 is 18. 18 plus 2 is 20. All right, y is equal to 20. Well, again, I'm asking for intercept, so this should be 0, 20. That's where it crosses the y-axis. Okay, now let's sketch, right? For your sketches, again, all you really need is your x-intercepts and your vertex. In this case, we had no x-intercepts, right? So again, this sketch should actually be pretty easy, right? Again, I have my x-axis, I have my y-axis. Let's go ahead and sketch this using our vertex. Our vertex was 3, 2. Okay, let's say that's 3, 2. Okay, now again, was this a happy face or sad face? Well, this was a happy face. So I knew, and I know just from the problems I did previously, that it does not cross the x-axis. It has no roots, right? So it's not going to cross anywhere here because it has no roots, it has no x-intercepts, solutions. They all mean the same thing. It does not cross this x-axis, right? So this is how my sketch should look like. Okay, my vertex, again, and this is a happy face, so it's just going straight up. Okay, now if this was a sad face, I would have to figure out what my x-intercepts are, but there's no x-intercepts in this case. All right, for number 2. For number 2, we have y is equal to 4x squared plus 9. Now we notice there's something missing, that b is missing, okay? Now this is in standard form, okay? Let's go ahead and write what our a, b, and c is because it'll help us throughout all these problems as well. Now a would be 4, b is missing, so b would be just 0, right? 0 times x is 0, and we don't see that within our equation. C would be 9. Our vertex, again, if this is in standard form, so we can go ahead and do negative b over 2a, and we can figure out, well, what would our vertex be? So negative b, well, that's 0. We just found that out. 2 times a is 4, or 2 times 2 times 4 being a, that would be 8. We end up getting the first part of our vertex, right? We go ahead and plug this back in here. 0 squared is 0. 0 times 4 is 0. Well, all we're left is y is equal to 9. Well, again, that was our y part of our vertex. So our vertex, in this case, would just be 0 and 9. Okay, remember, vertex gives you 2 other things, right? This is our x, this is our y, this showing our axis of symmetry. So where does this split up? Or where does the parabola split up? Find your max or min. Again, this is a happy face. This would have a minimum. But as far as what is the minimum, again, that would be y is equal to 9, right? How many solutions? If I'm saying how many solutions, b squared minus 4ac is the one quick rule that you should be looking at, right? I have my b, my a, and my c to plug in. So let's go ahead and find out how many solutions does this really have, okay? So b would be 0 minus 4 times a times c. Now we can quickly figure out that this would end up being 0 times 4 times 4 times 16 times 9. Again, that would be, real quick, 16 times 9. Okay, that would be 144, so minus 144. That would be a negative number, okay? That means this has 0 solutions, okay? Now, if it has 0 solutions, I know F, my next question, okay, would have no roots because you get a negative number when you're doing b squared minus 4ac, okay? It means it has no solutions, okay? So no roots for this one. Does not touch the x-axis. All right, number 3. Number 3, it's simply asking your quadratic formula, okay? The reason I'm asking is this because, well, you need to know it. I'm not going to give it to you. again, that is negative b plus or minus b squared minus 4ac all over 2a. So again, that's all I'm asking, your quadratic formula. You need to know it. Number 4. Okay, let's take a look at number 4. Now, for number 4, I have this equation, this following equation, and I remind you in the question that there are no roots. And I asked you to find the range of values for k. Okay, now I'm telling you there's no roots, right? There's a specific reason I'm telling you there's no roots. When there's no roots, what should you think of? Well, you should think of that b squared minus 4ac is going to be less than 0, right? Because that's the only time you have no roots. So now I need a couple things. I need to have a, I need to have b, and I need to have c. So you need to think to yourself, well, is this in standard form yet, right? Which it actually, it basically is, right? I have my a, I have my b, again that would be 2k, and I have my c, which is basically my constant. And I know it looks a bit weird, but this is my c, okay? This represents the c value, or the constant value, within my standard form. So this is actually in standard form, okay? So a would be 1. Okay, what is the coefficient of x squared? That'd just be 1. B would be 2k. And c would just be this value, right? We don't know what this constant is. And this is how they represent it. So k minus 1 and k minus 3. Okay? So we can go back and say, well, I know what b, a, and c are, and I know it's less than 0. So let's go ahead and plug a, b, and c back into this formula, okay? All right, so b squared is, well, that's just 2k, so I know this is gonna end up being 2k squared. I know 4 is just 4, a is 1, c is this big old value here, so k minus 1 and k minus 3. I know that's all less than 0, okay? I'm gonna have to simplify this real quick, right? 2k squared, well, it's just 4k squared. Minus 4 times k minus 1, k minus 3. I'm gonna FOIL this real quick, okay? So that should end up being, well, negative 4 times 1 is just negative 4. Let's FOIL this, okay? So first, outside, inside, last. I should end up with k squared minus 4k and plus 3. Again, that's all less than 0. Let's keep simplifying, okay? So negative 4 squared, this value, distributes to this term, and this term, right? So again, I have 4k squared on the outside. I have negative 4 times k squared is negative 4k squared. Times this is plus 16k. Negative 4 times 3 is negative 12. Again, all less than 0. 4k squared minus 4k squared, well, that goes away, right? Those cancel each other out. I have 16k minus 12 less than 0. I add 12 to each side. So plus 12 plus 12. Okay, divide by 16, divided by 16. I should end up with k, which is less than 12 over 16. Now, obviously, you could simplify this a little bit. So 12 over 16 would turn out to be 3 over 4. So this would be the value of k to get you no solution, or no roots, or no solutions, okay? All right, the next one, it says number 1, the product of two numbers is 20, the sum of squares is 41. Now, again, these are your word problems for quadratics. Now, these are tough, but again, you just have to, it's a matter of setting it up. It's all about the setup, okay? So if you can set up, most likely you'll be successful on this type of problem, but it's all about the setup, okay? So let's go ahead and try this out. So product of two numbers is 20. Again, product means things are being multiplied to each other. So I don't know what those two numbers are. That means x, y. The product of these two numbers is equal to 20, right? That's my first equation. My second equation mentions the sum of squares is 41. The sum, so I'm adding, of squares, well, it's the squares of these numbers, x squared plus y squared is equal to 41, all right? So I have my two equations, okay? This looks familiar because I can end up doing simultaneous equations, right? What I can do here is, first of all, tell yourself what is an x or y value that I can substitute back into number 2. So let's figure out our x here. So x is equal to, well, if I divide by y, that means x is equal to 20 divided by y. So at least I know what x is, so I can take advantage of it, and I can go ahead and plug it back into equation number 2. Okay, let's go ahead let's try that out. Right, let's plug this back into equation number 2. So I substituted back in x, which was equal to 20 over y, which I explained earlier. Right, I just have to simplify this a bit now. 20 over y squared is 400 over y squared plus y squared is equal to 41. Now, look, I have a fraction here. Let's get rid of fractions whenever we can. In this case, so multiply by y squared, multiply here by y squared. Again, if I do something to one term, I have to do it to everything. Okay, and again, it's an equation, so you do things equally. So this ends up being, well, this y squared ends up canceling out. 400 y squared times y squared is y to the 4th is equal to 41 y squared. Okay, so this is looking more and more like something that maybe we've dealt with before in quadratics, but a bit different because we have y to the 4th. Make sure everything is in order. So how about we move everything to one side? So minus 41 squared, do the same thing here. Okay, and we should end up with a brand new problem, which looks like y to the 4th. Okay, let's have that first. Okay, minus 41y squared plus 400 is equal to 0. Okay, so we can actually end up factoring this. Okay, we haven't spent any time on this, but if you know how to factor binomials or trinomials when it comes to the degree of squared, you can factor this trinomial as well, even though this is a 4 right here. You do it in a very similar fashion. Okay, so let's go ahead and do that in the next step. Alright, so I have y to the 4th minus 41y squared plus 400 is equal to 0. Again, think of terms that will multiply to get you y to the 4th. Most likely this is going to be y squared times y squared will end up getting you multiply to get you y 4th. So that's pretty easy, right? Let's figure out what multiplies to 400 but adds up to negative 41. So this is our magic number. Once we see this, we can go ahead and we know that we have the correct terms, at least on this side. Okay, so what multiplies to 400 that adds up to negative 41? Okay, again, this is a big number, so it might not come to you very quickly, but it should be negative 25 and negative 16. Okay, let's see if this actually works out. All right, so y squared not times negative 25 is negative 21 5y squared. Y squared times negative 16 is negative 16y squared. Now do these multiply to get you 400? Yes, they do. Do these add up to get you negative 41? And yes, they do. So we know that we have the correct factorization, which includes this and this. Okay, so y squared minus 25 and y squared minus 16 is our factors. So remember, this factor is even more, right? This is something that you've seen before. So y minus 5, y plus 5 is equal to y minus 25. And for here, y minus 4 times y plus 4 is equal to 0. Okay, that's how you end up factoring this. Your possible factors for y, or actually in x in this case, okay, basically end up being y is equal to 5, y could be equal to negative 5, y could be equal to 4 or negative 4. Now, these are your possible values for x as well, okay? So basically, because again, the product, those are interchangeable between x and y. The sum of squares, that's also interchangeable between x and y, okay? Because of the sum. Now, again, x could be the following. X and y could be the following. So it could be, your possible numbers of this could be, again, 5, it could be -5, it could be -4, and it could be 4. All of those would work in these possible situations. So here's what your answer should be. All right, for number 2. Number 2 was like a very badly worded question, okay? Again, I didn't make a question, so you can't really blame me for this one, right? But again, I do understand if you didn't quite understand what it was saying to you. But let me kind of break this down. So what it's saying is, for number 2, there is a wedding photo, okay? So this wedding photo, it's how the bride and the groom, right? Okay, so this wedding photo is a glass plate, and it says it's by 18 by 12. Okay, the length is 18, the width is 12. It's saying it's being fitted around a frame, okay, that is going to be the same area as this photo, okay? So, okay, so here's my frame. This frame is the same area, okay, as this wedding photo, okay? Now, what is the area of the actual wedding photo, okay? 18 times 12, okay? Well, that would be 216. So 216 is the area of the photo. 216 is also what ends up being the area of this frame, okay? Now, knowing that, this is actually very similar to the question we gave you on your quiz, okay? It's just a bit of a different look. Now, I still don't know. I do know the area of this frame is equal to the photo, okay? But I do not know the width of, or the dimensions of this frame, or this part of the frame. So again, I don't know what these widths are, okay? I don't know from here, I don't know from here, and I don't know from here, from all different sides, okay? So again, the equation that you're gonna set up is based upon what you have here. So again, how you set up a area problem for a rectangle, in this case, would be length times width, okay? So that's length times width is equal to your area, okay? And we know what our area is, okay? That's 216 plus 216, because I know the area of this whole thing, okay? If I know the area of this is 216, and I know the area of this purple shaded part is 216, well, my area ends up being 432. I know my length. Well, what is my length? It was 18, but I extended it by x and x, which we don't know. So that's 18 plus 2x, right? Times my width, again, it was 12, but I extended it by x, and x my unknowns. So 12 plus 2x would be equal to my whole area, which again is 216 plus the 216, that's the area of this frame. So this is how you should set it up. So this is how you should set it up. You should FOIL, okay? I think you end up with 2 values. One should be negative, one should be positive. You're obviously gonna take the positive measurement, right? So in this case, when you do everything, you should end up with x is equal to 3, okay? So that is number 2. Number three, we have a group of friends. They go to a restaurant. The bill ends up being $175, but Miss Bo and Miss Phi, they basically end up sneaking off before the bill ends up being paid. So the rest of the friends, and we don't know how many friends there were left at the end of the bill. But they're basically held accountable for this bill, and they end up paying an extra 10 baht each for each individual. Okay, so there's a couple of things you have to remember, right? Probably the best way to represent this is in two equations. The first situation, okay, we had y. Again, let's pretend y is the value that each person pays. Okay. Now our bill was 175. Let's divide it by the number of people, right? Okay. So again, y represents the number or the amount that each person pays. 175 being the bill divided by the number of people. Again, that's pretty simple and self-explanatory. But what ends up happening is, again, our new situation would end up being, okay, y, right, is equal to 175, but there's 2 people that left, right? So p minus 2. There's 2 people that left, so that's why I'm subtracting by 2. And what ends up happening is that these people, right, these people end up paying 10 baht more each, right? So again, this was the amount being paid. So the amount being paid is added by 10, right? So what you have here is basically another simultaneous equations. So you can end up being, well, you do know what y is equal to, so you can substitute it back in here. So this would end up being y, which is 175 over p plus 10 is equal to 175 over p people minus 2, right? So basically you want to set this up, or you want to go ahead and simplify this and figure out what ends up being p. What does each person, or how many people were there actually? All right, what you could do here is, again, we're dealing with a messy situation. We're dealing with fractions, and these denominators are not even the same. So we have to do something called our least common multiple, right? Let's put a 1 over here. So let's figure out what our least common multiple is. So let's multiply all our denominators, which are different, to our numerator, and hopefully that'll simplify this a little bit more. So p times 1 times p minus 2. Let's multiply everything by p and p minus 2. P and p minus 2. P and p minus 2. Okay, that way we can end up canceling things out, right? P and p end up canceling out. So I have p minus 2 times 175. So 175 times p minus 2. 10 times that, well, plus 10, we can simplify this, so p squared minus 2p. P minus 2 ends up canceling out here, so I just have 175p on my right side, right? You want to simplify this even more, okay? So let's go ahead and try this out. We have 175p times negative 2 times 175 is negative 350. Plus 10p squared, again I'm distributing, minus 20p is equal to 175p, right? I can actually subtract, when I subtract 175p from here, I subtract it from here, well, they end up canceling out, okay? And again, this looks like a lot better, right? So I have 10p squared, let's rearrange this a bit, 10p squared minus 20p minus 350 is equal to 0. First rule of factoring is take out my greatest common factor, which is 10. So it's p squared minus 2p minus 35. Okay, so you can actually end up factoring this a bit more. So how do I end up factoring this? Well, again, this should be p minus 7, p plus 5 is equal to 0 with 10 on the outside. P minus 7, again, this is the only one that works. This is the only one that works. You'll get a negative 5 is equal to P, but you'll get a positive 7 for P here. This one doesn't work. This is the only one that works. So there are 7 people that were basically there in the original, before 2 people stuck off. There are 7 people there. All right, number 4. We have Mr. Stanley, Mr. Richard. They decided to set out from 2 different towns on their bikes. They're 247 miles apart on a straight road from Salia. Now, Mr. Stanley has been cycling for 9 miles a day. The number of days for the whole adventure is 3 more than the number of miles that Mr. Richard has been cycling. So that's 3 more. This is a bit of a hint for Mr. Richard. It's 3 more than the number of miles. The days is the 3 more than number of miles that Mr. Richard has been cycling. So how many miles did each cycle? We can basically set this up in a quick little formula, right? And this should, make sense to you. So the total number of days, well, if we take the number of days and multiply it by the number of miles that each person rode, that should be the number of total miles, right? So times the total number of miles biked by Stanley and Richard, okay, and that's per day. That should equal, well, the total number of miles, right? Which makes sense. The days multiplied the miles is equal to the total number of miles in total, okay? So it gave us a couple clues, right? It told us that Mr. Stanley has been cycling 9 miles a day. Do we know how many miles Mr. Stanley rode? Well, we don't, right? So let's just call that X. Again, that signifies the number of miles Mr. Richard has rode, but we do know Stanley has rode 9 miles per day, right? All right, as far as the total number of days, it did mention that the number of days for the adventure is 3 more than the number of miles that Mr. Richard rode. Well, if X represents the number of miles that Mr. Richard did per day, and I know the number of days is 3 more than that, okay, we can symbolize the total number of days by saying X plus 3, right? The number of miles that Mr. Richard rode plus 3. That's the clue that they gave us. Now the number of total miles, okay, that would end up being, they did mention 247. Okay, so basically here's how you want to set this up. All right, here's how you want to set this up. Let's simplify, okay? So let's find out how this simplifies. Let's FOIL x squared plus 12x plus 27 is equal to 247. And you can go on and do minus 247 and figure out what this actually is when it comes to either factoring or do quadratic formula, right? So this is the formula that I basically, when I simplify it, that I get. I end up getting x, this is plus 12, this is x minus 10 equal to 0. Well, again, if I'm saying x is equal to negative 12, this equals 0, this would be equal to 10. Well, the number, in this case, what does x represent is the number of miles that Mr. Richard rode, okay? Can it be negative 12 miles? Well, heck no, right? The only possible answer is x is equal to 10. So, you can basically figure out how many miles that each person rode based upon what we had earlier, right? So we do know that Mr. Stanley rode 9 miles per day, okay? We need to figure out, well, the number of days. Remember, the total number of days were symbolized as being x plus 3, I know what x is now. So 10 plus 3 is 13 times Stanley and the number of miles. Okay, that would be 9. So I have 13 times 9. It should equal the total number of miles that he rode. Okay, so it should be 117. So 117 represents Stanley's, the number of miles that he rode in total. Okay. Now, if I know that there are 247 miles in total, right? And I just figured out that Stanley's miles were 117. Okay, I can subtract the total from Stanley's miles, okay, and I end up getting 130. So 130 miles represents Mr. Richard's total number of miles that he rode. Let's go on to simultaneous equations, right? Now, this is a linear, a nonlinear. We should be substituting here, okay? Now, let's substitute for a y. So negative y is equal to negative 2x plus 7. Well, that's a negative y. We need to make sure we multiply by a negative 1 here and a negative 1 here. So y ends up being a positive 2x minus 7. All right? So this is exactly what we need to substitute in here, right? So xy is equal to 15. Let's go ahead and put that in. So again, y being 2x minus 7, x just being x. Okay, let's distribute. We end up getting 2x squared minus 7x is equal to 15. Let's subtract by 15. 2x squared minus 7x minus 15 is equal to 0. All right, let's try to end up doing factoring here. So let's see how this ends up. Okay, we can do our crisscross. So what multiplies to get us 2x squared? Well, that would just be 2x and x. What will multiply to get us negative 7x? Okay, think of factors of negative 15 that will add up to negative 7 when it comes to these two things. Okay, so let's try out 3 and 5. Let's make this a negative 5. Okay, so 2x, or x times 3 is 3x. 2x times negative 5 is a negative 10x. Okay, we end up getting negative 7x, which is exactly what we needed. So I know that this works. I know 2x plus 3 is one of my factors, and 2x minus 5 is one of my factors. Okay? All right, so I have 2x plus 3 as one of my factors, and x minus 5 as my other factor. All right, we set this both equal to 0. We end up getting x is equal to negative 3 over 2. And we set this equal to 0. Well, that would just be x is equal to 5. Okay, now what are we going to do with these values? We're going to substitute them back into, let's say, number 1, because it's a bit easier. When we substitute it back in, we should end up with our answers. Our following answer should be, should have 2. Again, we have 2 x's, we'll have 2 y's. So in coordinate form, it'll be negative 3 over 2. When we plug this in, we'll get negative 10 back. And the other answer is 5 and 3, which again, when we plug in 5 into number 1, we'll end up getting 3 back. So these are your following answers. All right, number 2. Number 2 has, again, non-linear, linear. We should take advantage of the linear. Let's find out x. We have to do minus 2, so I know x is equal to 2y minus 2, right? Subtract 2, we get x is equal to 2y minus 2. I know exactly what I need to plug in for x in the first equation, right? So let's figure out what we have. We have x squared. We might need a bit more room here. Okay, we ended up getting 2y minus 2 for x. That's squared minus y squared is equal to 7. Let's FOIL here. So first outside, inside, last. Okay, so first outside, inside, last. So that would be 4y squared. Outside, negative 4y, inside negative 4y, so that's negative 8y, last plus 4, and then minus y squared is equal to 7. Let's simplify this even more. 4y negative y squared is 3y squared, and we have negative 8y, that doesn't go with anyone. Minus 7, we get minus 3 is equal to 0. Okay, we gotta end up trying to factor this. So let's use our crisscross. Let's figure out what these end up, these could be possibly. So 3y squared, well, our factors would be 3y times y. We gotta figure out what multiplies to negative 3 but adds up to negative 8. Okay, so let's try out 1 and negative 3. 3y times negative 3, that's negative 9y. Y times 1 is y, that would end up being negative 8y. That's exactly what we needed. So our factors are 3y and plus 1, y minus 3. Okay, so what we had was 3y plus 1, y minus 3 equal to 0. Set this equal to 0. Okay, we end up getting y is equal to negative 1 over 3. And we end up getting y is equal to 3 here. Okay, so at least we have our y values. Now what do we do with these y values? We plug them back into the linear equation, the easier equation. Okay, so your answers should be the following. Okay, your answer should be 4, 3, and negative 8 over 3, and negative 1 over 3. Okay, so those are your answers. All right, so number three, again, I think the best way to do this is elimination, right? Substitution would be a little too messy. Let's do elimination and let's figure out how we can eliminate some of these terms. Let's try to knock out our x's, or let's just try to knock out our y's, right? So 3y and 2y, we can multiply this one by a negative 2. We can multiply this one by a positive 3. Okay, so we'll end up having brand new equations, right? So what are our equations? Well, it should be negative 4x, negative 6y is equal to a negative 16. We end up with 9x plus 6y is equal to 21. Okay, these of course will knock out, right? Just like how we wanted them to be. Negative 4x plus 9x is 5x is equal to negative 16 plus 21 is 5. Well, x is equal to 1. Okay, if we end up plugging this in, like say for here, okay, 2 times 1 is 2, minus 2 from 8 to 6, 3y is equal to 6, well, y is equal to 2. So your answer for this should be 1 and 2. All right, number 4 is all about the setup. I have two numbers that have a sum of 58. So two numbers that have a sum, xy plus 58. The difference between the two numbers is, again, difference meaning minus is 22, okay? Again, we have our equations here, and it's pretty easy because elimination setup is set up already. So y minus y, well, that ends up canceling out. I have 2x is equal to 80, okay? X is equal to 40. If I plug this back in, I know y would end up being 18. So the sets problem, we have the following situation. I know universal set is 8, 9, 10, 11, 12. Based upon this universal set, I need to answer set A, set B, and set C. Okay, I'm restricted by my universal set. Remember, universal set is my boss. So I cannot go outside of these numbers. Now for A, it says 2n is such that n is an element of an integer, okay? Well, again, integers are positive or negative, but again, I have all positive numbers here. It also says 2n, so any number I pick has to be a multiple of 2, right? The only possibility for that would be 8, 10, and 12, right? So this would suffice for A. For B, okay, for B we have 3n is such that n is a positive integer. Okay, well that doesn't really change much. Again, these are all positive integers, so I was going to pick a positive integer anyway. Multiples of 3, well that would be 9 and 12. That's all I got. C, n is such that n is less than 10 when n is a natural number. Okay, your baby numbers. So less than 10. Well, less than 10, I can start doing 1, 2, 3. Oh, hold on. It's not in my universal set, right? So I cannot choose that. Okay, so this would just be, what, 8, 9, and that's it, right? Just 8 and 9. All right, let's do D and E. So A complement basically means what is in A, but not mentioned. So what is not mentioned in A, but it's in your universal set. So 8 is mentioned, 10 is mentioned, 12 is mentioned. What was not mentioned in A, but still in your universal set, would be 9 and 11, right? So that would be 9, 11, and that would be the complement of A. Considering E, E says A is the subset, again this is subset of B, okay? A is the subset of B. Well, A being the subset of B, well not of all of A is found in B, so this would be a no. Is A proper subset of B, okay? Now it'd still be a no, right? 8, 10, 12, nothing is in B, so this would still be a no, okay? All right, letter F says B is a subset of 9, 12. Okay, that is true, right? 9 to 12 is a subset of 9 to 12. So all the numbers found in B are found in 9 to 12, right? So this would be a yes. Is B a proper subset of 9 to 12? Well, this would be a no for the mere fact that these sets are equal to each other, right? 9 to 12 and 9 to 12, well, those are subsets, but not proper subsets because they're equal sets. Whenever you have equal sets, they're subsets, but they're not proper subsets, okay? So A intersection B. Again, this means intersection, which means what's in common, right? What's in common between A and B? Well, the only thing common between A and B is 12 and 12, so this would just be 12 being the element that's shared between the two sets. For H says not complements of A, union B. Okay, remember this is OR. Now the complements of A, so what is found in A, or what is not found in A, but that's in your universal set. Okay, that would be 9 and 12. Okay, that's not mentioned in A. Okay. Union B, well, B is 9 to 12. Okay. All right. So H is not A union B. So what is mentioned, not in A, but mentioned in universal set? Okay, so this one's missing 9 and 11. Okay, so that would be 9 and 11 for complement A. Union, again, this is OR. Union B. So union B, we have B right here. So 9 and 12. Well, again, union of this and this, right? So 9, 11, and 12 should be what you have here. So 9, 11, and 12 is your answer. So I, again, do this one step at a time. So A ends up being 8, 10, and 12. Intersection B, well, that's just 9 and 12. What do they share in common? That would be 12 and 12, right? A intersection B, 12 and 12. So all this is 12 and 12, right? Sorry, 12. Okay? Now, it says complement of 12, right? Or complement of A intersection B. Okay, so what exactly is in the set, but not mentioned in the set, but still in your universal set? Okay, well, that would be 8, 9, 10, and 11. Okay, so this should be your answer. All right, for J, we have set A, which is 8, 10, and 12. Intersection B complement. Okay, so what was mentioned in your universal set, but not mentioned in your set B? Okay, that would be 8, 10, and 11. Okay. Okay, so what's the intersection? What do these share in common? Okay, that would be 8 and 8, 10 and 10. So for this answer, it should be just 8 and 10. Okay, so that's your answer. All right, for this question, we have 35 students in a class. Each studies at least one of the subjects, either music, okay, or ecology. Of these 24 students, 24 study music, 16 study ecology. Okay, find the number of people who study both. We do not know who studies both. Okay, but what we can do is we basically have enough information where we can at least set this up. Okay, now it does mention everyone studies everything, so there shouldn't be anything in your universal set. Okay, or sorry, outside of these two sets. Okay. So 24 minus x, 16 minus x, okay? We have everything we need here. Again, there's no one outside who's not studying music or ecology. So, how can I set this up? I know 24 minus x plus 16 minus x, okay, is equal to 35 students. So 24 minus x plus 16 minus x is equal to 35. Okay, so we should end up with 24 plus 16 is 40. Negative x plus x, they cancel out, but minus x is on the other end. Okay, minus 40, we should end up with x is equal to 5 here. Okay, so there should be 5 people that study both of those subjects. 24 minus 5 is 19. 16 minus 5 is 11. So this works out. This is equal to our universal set, which is 35. Alright, so for logic, let's figure out whether these are propositions. If they're propositions, tell whether true, false, or indeterminate. 3, 5, 7, and 77 are prime numbers. Well, 3 is a prime number, 5 is a prime number, 7 is a prime number. 77 is not a prime number. So again, this is a proposition. Remember, propositions are either true or false. This is a proposition, but it's false. Letter B, English alphabet has 26 letters. Again, this statement is a proposition. okay? Because we can say either it's true or false, and it ends up being true. It does have, English alphabet does have 26 letters. Where is my car? Well, that's a question, and it's not a proposition. They own an iPhone. Well, depends on who you're talking about, right? I might own an iPhone, but you might not. So it is a proposition, but depends on who you're talking about. So this is indeterminate. Okay? And E, Apple makes the best phones. Well, again, that's a matter of opinion. So this is not a proposition. All right, next question. We for number 2, again, we're stating whether this A, B, or C is true or false. Okay, we gotta figure out what these true, P or Q, whether those are true or false in those cases as well. The sum of 5 and 4 is 9. Okay, so that's true. 5 is a factor of 24. Well, that's obviously false, right? So again, P, okay, P or Q, again, this is or. If I have true or false, your end statement, again, true or false, I would encourage you to look back on your truth tables. True or false would end up being true. Okay, true or false, this or that. P and Q, okay, conjunction. Again, this is true and false. Well, I'm saying true and false. So both of these would have to be true in order for this to be true. So this would be false. Okay, P exclusive disjunction Q. So P or, but not both Q. Okay, so I have true or, but not both. False. Okay, so again, both of these are not true. Okay, so it's not going to be false. Both of these are not false, so it's not going to be false. So this would be true. So whenever there's at least, or whenever there's one true and the other one is false, it's going to be true. Let's go ahead and try number 3. Figure out whether it's tautology, logical contradiction, or neither. So number 3, this is going to be a bit of a long one. Okay, let's try to fit everything here. So P, start with your P's and Q's. We might need more room here. P's and Q's. Negate P is represented. Negate Q is represented. We have negate P and Q, so make sure you represent that. We have P and negate Q represented, so again, make sure you represent that. And then finally, this whole statement, which is negate P and Q, or P and negate Q. Okay? All right, let's split this up a little bit. Okay, so of course I have true, true. I need one more bar. Okay, true, 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 false, false, true, and then false, false. Negates P, again, let's go down the line. That's false, false, true, and true. Negates Q, well, that's false, true, false, and true. Okay, let's figure out negates P and Q. So we're looking at negates P and Q. Okay, and true and false. Well, that would be false. False and false. False. True and true. True. False and true. That would be false. Now let's look at P and negates Q. So looking at this one and this one. True and false, well, that would be false. True and true, that would be true. False and false, okay, that's false. False and true, that's false. Okay, now let's look at the whole thing, right? Negate P and Q, or P and negate Q. So we're looking at these two columns, but we're sticking an or in the middle. So false or false, well, that would be false, right? False or true, well, that would be true. True or false, true. False or false, that would just be false. Okay, the only time in an or statement it's true is when at least one of them is true. So false, true, true. False, true, true, false. So this would be neither. Okay, it's neither tautology or logical contradiction. Number 4, we have P or negates Q, implication Q, right? So we have P, we have Q represented, we have negates Q represented. Finally, we have P or negates Q represented. Okay, and then P or negates Q, implication Q, to kind of summarize this whole thing up. Okay, let's split this up. All right, so P's and Q's, again, true, 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 false, false, true, false, false. Make sure everything's represented. Negate Q, that would be false, true, false, and true. Okay, P or negates Q, well, that would be true or false, that would be true. True or true, true. False or false, that's false. False or true, that would be true. Okay, so now we're looking at basically this statement and this statement. Okay, if then, right? So if true, then true, well, that's true. If true, okay, then false, well, that's going to be false. This is the only time it's going to be false. If false, then true, true. Okay, if true, and then false, well, that's false. So this one is actually neither as well.